Okay, now we are going to learn about your AC circuit through resistor and capacitor, which in a textbook it being known as RC series circuit, which is your circuit is connected by a resistor and also a capacitor. Okay, which is connected to the AC circuit. So same at here, for the source voltage I denote it as V, and your voltage across R we denote it as VR. Well, your VC is your V of your capacitor, which across your capacitor. And this one, resistor with resistance R, and also capacitor with capacitance C. So what you have learned in your previous lesson is in your pure resistor, your I for a pure resistor. So we know that I and VR are in phase. While for your capacitor, your I is leading voltage across your capacitor by 90 degree or I/2 radian. This is what you have learned in your previous lesson. So I at here is the current that passes through your R and also C, because it's a series circuit. So we know that the I passes through R and C are the same because it is a series circuit. So here we have a phasor diagram. I believe that you already know how to draw your phasor diagram. So for this, the phasor diagram can be drawing as here. So draw the one which is in phase, which is this one. VR and I are in phase, while I is leading VC. So your VC will be in a negative cos wave front diagram. This one is your VC. In other words, you have your equation VR is equal to V0 R sine omega t, while your VC will be V0 C, negative V0 C cos omega t, but your I for your circuit will be I0 sine omega t. Okay, so you will have a wavefront showing like this. So your VR and I are in phase, and there is a sine wavefront. So you have a sine wave for this one, and while your VC will be negative cos wavefront. So you have this negative cos wavefront. So as a conclusion here, you know that your VC is lagging I and VR by 90 degree or pi/2 radian. Okay, so still the same. So if you look at this diagram, phasor diagram, so you get that for a vector VR is in this direction and your VC will be in this direction. So for your source voltage here is the vector sum of your voltage across your resistor plus the vectors plus your vector across your capacitor. In other words, this is your source voltage. So your source voltage V will be equal to vector sum of your resistor plus your vector sum of your VC. So this is your source voltage for phasor VR and also VC. In other words, your V, the magnitude of V, this is your vector, So, well, magnitude will be equal to V equal to VR square plus VC square root, because it still follows the Pythagoras theorem. Okay, so V will be equal to VR square plus VC square. So you know that VR is actually IR, and also your VC is equal to IXC. So XC is your reactance across your capacitor, which your XC is equal to 1 per omega C. So this equation can be written as V equal to I square R plus XC square. So you can remember this one. In your previous lesson, I've already shown you how do you factor out your I square. So here I just skip that step. So V will be equal to I R square plus XC square. Okay, don't forget your square root. So I for your circuit will be written as V over square root of I square R plus XC square. So if you compare this one with your Ohm's law, which is I is equal to V per R, but this for this one, the R at here is actually your impedance, which you use Z to represent it. Okay, so here you know that Z is your impedance, which is square root of your R square plus XC square. Okay, so this is your impedance. Remember, your impedance is the vector sum of your resistance and also your capacitance, which you denote it or define it as your peak voltage divided by your I voltage. This is your peak source voltage divided by your peak current. Of course, this can be written as your impedance can be written as v.r.m.s and also i.r.m.s. So this one is your source v.r.m.s, but this one is your i.r.m.s of your circuit. So you have to be very careful. So if you want to do it in terms of omega, so your Z will be equal to square root of R square plus XC is equal to 1 per omega C square. Okay, and of course you can written it in terms of frequency. So I just show you how to written it in frequency, because omega is 2 pi f, so you have this equation for your impedance. Okay, so if you look at this one, phasor, so you have know what is impedance, but throughout your RC circuit, there's another things you have to remember, because your source voltage is actually leading your VC and VR, is lagging your VR. So now, to make the conclusion that V is lagging VR and I by an angle theta, which is this angle. Your V, your source voltage is lagging, means is lagging your VR, and also I by theta. How do you calculate I? So this one is your source voltage V. So how do you calculate your angle theta in this? So tangent theta is equal to VC per VR. We look at this one. So tangent theta is equal to VC per VR. In other words, I XC per IR. So you will get XC per R. So theta will be equal to inverse XC per R. So V is lagging VR and I by theta, or you can written it as V is leading VC by 90 minus theta degree. Okay, clear? Okay, now what about your mean power? So for your mean power, still remember, mean power through resistor, still the same. For your resistor is V0 I0 per 2, or V r.m.s times your I r.m.s, okay, or I r.m.s square R. Well, your mean power across your capacitor will be equal to 0. Why? Because the power that absorbed by the capacitor will be released, will be same as your power that released to the circuit. So your mean power through the capacitor will be equal to 0. So that's it for your RC series circuit. So what you have to be very careful is this one. And then what is your conclusion of your VC, and this one, and also your impedance. Okay, and of course you have to know how to draw your wavefront diagram and also your phasor diagram. Okay, so you have to complete your exercise 18.7. So please complete your exercise in your page 318, exercise 18.7. Thank you. So see you in your next lesson.